Okay, so let's look at the problem from the review sheet. And the first problem, this is for exam 3. The first problem is the supply and the demand equations, right? For the first problem, this is the P equals 55 minus 0.10 Q. This is the demand equation, and this is P represents the price and the Q represents the quantity, right? And we have another one, which is the supply equation, which is P equals 0.02 Q plus 25. Okay, so this is two variables, right? P and Q, two linear equations. So this is the system of linear equations. So since this P is already given, we can use the substitution method, right? We just replace this P into the second equation, right? Plug into the second equation. Then you will have what? 55 minus 0.1 Q equals 0.2 Q plus 25, right? Then we add 0.1 Q on both sides. Then you will have 55 equals 0.3 Q, right? Plus 25. Then we subtract 25 on both sides. So you will have 30 equals 0.3 Q. So Q equals 100, right? This is the equilibrium quantity. Then what is the price? Then you can just plug it into any equation, any one of the equations, right? For example, we plug it into the first equation. So P is equal to 55 minus 0.1 times 100. So this is the $45, right? This is called the equilibrium price, right? This is $45. So this is your answer. P equals 45 and Q equals 100. So this is the first example. The second one, solve the system. The system, which is x plus 2y equals 6, and 6x plus 3y equals 9 by the substitution. Okay, so the method is given, the substitution method. So here, which one you want to choose to do the substitution? You want to solve one variable in terms of the other one, right? Which one is the easiest, convenient one? The top one, right? So we can write the top one gives you that, the first one gives you that what? X equals 6 minus 2y, right? Then we plug this one into here, into the second equation, not the first equation, okay? Into the second, the other equation. So you will have what? 6 times 6 minus 2y plus 3y equals 9. Is this correct? Parentheses, yes, parentheses. 6x, right? This represents x. Okay, so you expand it. So this is 36 minus 12y plus 3y equals 9. So 36 minus 9y equals 9. So 9y equals what? 27, right? 9y equals 27. So y equals 3. Y equals 3. So this is one thing. And we also needed to know x. What is x? We can plug in here. Or plug in here. Or plug in here. Okay. Anyway, anyone will work. Okay. So we plug in x plus 2 times what? Y equals 3. 3 equals 6. So x plus 6 equals 6. So x equals 0. So you have the solution, which is x equals 0, y equals 3. all the point you can write as a point form. This is the 0, 3 point. Okay, so this is the second problem. The third one is give you the same linear system, but ask you to use in the elimination method. The third one, this is the x plus 2y equals 6. 6x plus 3y equals 9. Okay, so we want to use the elimination. So which variable you want to eliminate? Which one is easier? Right, x, we eliminate x, right? Of course, you can eliminate y, right? But you need to find the least common factor, the common multiply for the 2 and the 3, right? And then make, which is 6. And then you need to make one equation to be the negative, the other one to be the positive 6, right? Then you add them up. Okay, so here we have coefficient 1 for x, here 6. So we know if you want to eliminate x, you need to multiply what? The equation 1 by which number? 6. Negative 6. Yeah, negative 6. Okay, we don't want to use any subtraction. Okay, we don't want to use subtraction. We just use the addition to eliminate, right? Okay, but if you want to do the subtraction, you can just add a negative number, right? So here is we multiply negative 6 on both sides. So negative 6x minus 12y equals, keep in mind, you multiply negative 6, okay? Sometimes students, okay, they know multiply negative 6, but later then they calculate this, it becomes 12y, then becomes 36. No, you keep in mind, you are multiplied by a negative 6, okay? So it's negative 36. So 6x plus 3y equals 9. Okay, so now we can eliminate. We can eliminate the x, right? We add these two equations up, add them up. So you will have, this is the 0, right? Negative 6 plus 6x equals 0. Negative 12y plus 3y equals negative 9y equals negative 36 plus 9 equals negative 27. So y equals what? 3 again, right? Y equals 3. Then we plug in the first equation, x plus 2 times 3 equals 6. So x equals what? X equals 0, right? You will get the same answer, right? So this gives you an idea how to check your answer, right? You're using different method, or you just plug in back, right? How to check your answer? You just plug in back into the equation for your solution, right? You're just plugging back into the equations, both equations, to see if these both equations true, right? So for the linear system, you can always check your solution, okay? So this is number 3. Number 4. Number 4, okay, so this is just a kind of, yeah. So there are 3 possible outcomes for the graphing the system of linear equations, right? Because it's hard to test you, so we just use some word problem. That's this kind of word problem to help you to understand. So we have 3 cases, right? The first case is you have 2 parallel lines. If 2 lines, 2 equations, each equation represents a line, okay, straight line. If 2 lines are parallel, that means there is no solution, right? No solution. If 2 lines intersect at one point, there's only one solution. Right? The answer says, okay, independent solution. Yeah, it's the same thing. Okay, well, there is only one solution. 3, 2 lines are actually the same line. They coincide. Okay, the same graph. So that means you will have infinitely many solutions. Okay, so this case we call the and dependent solutions. It's exact same thing. Okay, this is number 4, right? This is number 4. Number 5. Number 5 is to draw some inequality, graph the inequalities. Y less than -2. So this kind of easy one you should got, okay? -1. So first you need to look at what is the boundary. Right? Y equals -2. -2. That's -2. What is the -2? -2 is here. 1, 2, right? This is -2. But we notice that this is there's no equal sign, so we use what? Dash line, right? This is a horizontal line, so it's the dash line. Okay, then we test the sample point, right? We test this point, for example, because this point is not on the graph. So we test this 0, 0. We plug in 0, 0 into the original inequality. So it's y equals 0, 0 less than -2. Is that correct? No. No. So this is wrong. This is wrong. That means that this up half plane will not be your solution, right? So you must have the lower half plane. So this is the solution region. Number 6. 4x plus y less than equal to -2. Okay, so the first thing is we still need the boundary, right? Which is 4x plus y equals -2. Right? So we need what? We need 2 points to locate. So we can take what? The x-intercept and the y-intercept. This is the thing we always use, right? The x-intercept, x-intercept. So let's look at the y-intercept first. The x equals 0. X equals 0. When x equals 0, you plug in here 4 times 0 plus y equals -2. So y equals what? -2, right? So 0, -2 would be your 1 point. So which is here 1, 2, right? So this is 0, -2. Then we need another point where y equals 0. Y equals 0. X equals what? -1/2. Okay, it's okay. It's a fraction, although it's a fraction, but it's a very simple fraction, right? Not like the 15 over 17, this kind of fraction. It's 1/2, -1/2, -1/2. So here's 1, 2. This is -1, -1/2 would be here, right? So this is the -1/2 0 point, right? Then we connect, so we use the solid line or dash line. Solid because we have the equal sign here, right? So we use the solid line to connect these 2 points. Then we need this part or this part, right? It's separated into 2 parts. So which part represents the solution, right? The region for this inequality. We need to test, give a test point, arbitrary point. So here we just choose this origin because the origin is not on the line. We need to choose a point which is not on the line, okay? We test the 0, 0 point. 0, 0 point, so we plug in 4 times 0 plus y equals 0, less than equal to -2. Is this correct? Not correct, okay? It's wrong, so we should choose which part? The lower part or the upper part? Which part? Lower one or the left one, right? So this is your region. Number 7. Okay, so determine whether the given order pair is a solution of a system. Okay, so this kind of problem, I think everyone should go to the point. So this is a point, okay? This is the point, and this is the system. 3x equals -6 minus 1. 4x equals -3 minus 3, 1. So how to test if this point is the solution for this linear system? We just plug in the points, right? Plugging this point into the system to see if these two equations are true, right? So for example, let's plug in the first one. We need to plug in both, okay? You need to check the solution by plugging the point into both equations, not just one equation, okay? So x equals 3, y equals 3. So 3 times 3 equals -6 minus 3. Is this correct? No, it's not correct, right? Of course, if it's not correct, you can say, okay, it's not a solution, right? But if it's correct, you need to plug in the second one. Okay, let's plug in the second one, just in case. 4 times 3 equals -3 minus 3 times 3. No, this is not correct, right? So of course, this is not a solution. This is not a solution for this system, right? So for this kind of problem, just plug in point into the system to see if the system is true or not. If one of them is wrong, then it's not a solution. You should satisfy if it is a solution, you need to satisfy both equations, right? Number 8. Okay, so this is a word problem. Ask you to find the objective function. Right? As I said, we will not test a whole problem, right? Sometimes we just test a part of them. So we have done this kind of linear programming problem many times, right? So here is x represents the ounce of chicken. X represents the ounce of chicken. And y is the number of the ounce for the potatoes. Okay. Each ounce of the chicken is 0.35, right? Okay, we can use a table if you want, but this is a very easy one. All right, this is the chicken. This is the potato. So per ounce, which the price is 0.35 per ounce, right? Chicken, potato is 0.02. Okay. Then what is the objective function? The objective function describes the total cost. Okay, total cost. So purchase X ounce chicken and Y ounce potatoes. Okay, so what is the total cost? We use Z represent the total cost. Total cost. So Z equals what? 0.35 times X, right? This is the total cost for the chicken. And plus for the potatoes is Y times, okay, so we can write number first. 0.02y. Right? So this is your objective function. Okay, so this is just objective function. So this is for this problem. Number 9. Solve the linear inequalities. Okay, system linear inequalities. X plus 2y equals greater than equal to. Greater than equal to 2, x minus y less than equal to 0. So we know that we need to draw the region for each one, right? For each one, then find the common parts. So this is the first one. We want to draw the region for the first inequality, we need to look at the boundary, where the boundary is x plus 2y equals to, right? Equals to, this is the boundary. Okay, so we draw the graph here. So we need two points, right? X equals 0, y equals 1, right? This is 1 point. Y equals 0, x equals what? 2. Okay, so 0, 1 is here. 1. The 2, 0 is here. 1, 2. This is 2, 0. This is 0, 1. Okay. And when we use the line to connect these 2 points, we should use the solid line or the dashed line. Solid line, because here is greater than equal to. Okay, you have the equal sign. So solid line to. Okay, and let's look at which part it belongs to. Okay, so we test, give a test point. Test point, we can use the origin. So we plug it into the original inequalities. So 0 plus 2 times 0 greater than equal to 2. Is this correct? It's yes. 0 greater than equal to 2? No. That's wrong. So we should have the plane which does not include the origin. Right, this is 0, 0 point, right? We should have 2 planes. One plane, one part is this part, right? Above this line, which is the part does not include this origin. The other part is the part includes this origin. Okay. So we choose this part. Okay, so this is for the first equation, the first inequality. Let's look at the second inequality, which is x minus y less than or equal to 0. So let's look at the boundary, which is x minus y equals 0. X minus y equals 0, we know it's a straight line, right? One thing you can choose x equals 0, y equals 0, right? 0 minus 0 equals 0. The other point is you can choose x equals 1, y equals 1, right? So here is 1, 1 point. Here is 0, 0 point. So we use another color. This is 1, 1 point. Okay, so this blue line divide our plane into 2 parts, right? One is this part, the other one is this part. Okay, so which part we needed to test a point, right? But this time we cannot test the 0, 0 point because the 0, 0 point is on the line, right? So we need just choose arbitrary one. We can choose, say we just test what? Just test the 3, 0 point. 3, 0 point. 3, 0 is here, right? 3, 0. You can choose 2, 3. Okay, 4, 0, 0, 4, 0, 3. It doesn't matter, right? Just choose arbitrary point. Okay, so we choose the 3 points. So 3, 0, 3 minus plug into here, right? Plug into here. 3 minus 0 less than or equal to 0. Is this correct? No, this is wrong. So in other words, we should not choose the region. So this region is not your solution region, right? Because it contains the 3, 0 point. So we choose the other part, right? The upper part. So we have this part. So what is the common region? The common region is this red color, which is this is the one boundary, right? Can you see it? This is another boundary. And the between. This is your solution region for this linear system and a linear inequality system. Any questions? Number 10. Y greater than -3, x greater than equal to -5. So these are two lines, which is one is the horizontal line, the other one is the vertical line, right? We can just draw the graph first. So for the first one, we need to look at y equals -3. -3. 1, 2, 3, right? And then we should use what? Dash line. So y greater than -3. Where is greater than -3? Above the dash line or below the dash line? Above, right? This one, you of course you can test a point, but this is very easy. You don't need to test the point, right? Because above greater than -3, so above -3, right? So which is here. Okay, and then let's look at the second one. Second one is x greater than equal to -5. The boundary is x equals -5. -5 is here. 1, 2, 3, 4, 5. Okay, this is -5. This is -3. This is -5. So we use so x equals -5, which is a horizontal vertical line, right? So we need to draw a solid line or dashed line. Solid line. Because you have the equal sign here, right? So on the left or on the right? On the right, greater than equal to -5. So on the right, right? So what is the common part we use? This time we use the blue color. So this is the common. And here is dash line. And between these two lines. Okay. Number 11. Which is also linear programming problem. Okay, linear programming problem. So made two things, right? Hat and Afghan. Okay, so hat. Okay, for hat, 8 hours to make a hat, 3 hours to make an Afghan. She has no more than 48 hours available. So that means the total hour should be less than equal to 48. Okay, she has a material for no more than 11 items. So if this item is X and this item is Y, right? So it should be less than equal to 11. Total number should be less than equal to 11. If we let X to be the number, so this is given, okay? The let X is the number of the hats she made, and Y equals the number of the Afghans she makes. Okay. And then we have another condition that she wants to make at least 2 Afghan. So that means here should be what? What's the meaning for at least 2? Yeah, greater than equal to. Greater than equal to 2. Okay, so now let's write down the conclusion. Okay. So we have the first restriction, which is this one, right? 8x plus 3y should be less than equal to 48. This is the one restriction, right? One constraint. This is the total hour should be less than equal to 48. And the total number, which is less than equal to 11. So x plus y should be less than equal to 11. So here, y, Afghan at least 2, right? So y should be greater than equal to 2. Of course, here I think the answer is not totally correct. We should add another condition, which is what? Should be greater than equal to 0, right? Yes, that would be your correct answer. But if it doesn't give you the x greater than equal to 2, then you can just compare. So this is the only B, choice B would be your best choice, right? We cannot say it's the correct choice, but it should be the best choice. Okay, the best choice is B. Number 12. Okay, the region is given. This is the region. Just draw a quick region. Okay, this point is 0, 9. This point is, this is the feasible region. 3, 0. This is 9, 2. 9, 9. And this is the feasible region. And the objective function, which is z equals 5x plus 8y. So since this region is a closed region, right? This is a closed feasible region. So it must have the maximum values and the minimum values, right? If it's open, unbounded, this is bounded, right? No, sorry, we should not see closed. Closed, this kind of word. Yeah, you don't know this kind of word. So I should say it's called bounded, right? Bounded. So every side has a boundary, right? If it's a bounded region, feasible region, you must have what? The maximum values and the minimum values. If it's unbounded, it depends, right? Okay, so now here is the bounded feasible region. So it asks you to find the maximum values and the minimum values. So we know that the maximum values and the minimum values only happens at where? At the corner points of this region, right? We have 1, 2, 3, 4, 5 corner points. So we just need to plug in these 5 corner points into the objective function to see which number is the largest one, which number is the smallest one, right? So we make a table. The first column, write down the corner points. Let's write down the corner points counterclockwise. And this is the z value. Z equals what? Z equals this one, right? 5x plus 8y. So we plug in. Here is 5 times 0 plus 8 times 9. So this would be 97, right? And here is 5 times 0 plus 3 times 8, right? So this is 24. This one is 5 times 3 plus 8 times 0. This is the 15. So we're plugging here, right? Plugging this one. And 5 times 9 plus 8 times 2. So this is the 45 plus 16, which is 61. And this is plugging 99. So it's 5 times 9 plus 8 times 9. So this one is equal to what? Equal to 45 plus 72. So this is the 117. Okay. So which one gives you the minimum values? So this is the minimum value, right? This is the smallest one. So the minimum values is 15. It happens at the 0.30 point, okay? So 30 tells you the position, not the minimum value. Minimum value means the z values, okay, which is 15. This is the maximum value. The maximum value is 117. It happens at the 0.99 point. 99 point is the position, right, the location of the maximum value. Okay, so this is this problem. Number 13, which asks you to solve. Okay, the linear programming is given. It asks you to solve it. The linear programming is given. We want to maximize z equals 6x plus 7y. Subject to, that means the constraints, okay? The following is a constraint. 2x plus 3y less than equal to 12. 2x plus y less than equal to 8. X greater than equal to 0, y greater than equal to 0. Okay, so we need to draw the graph, right? For this is called the feasible region, right? We need to look at the feasible region. Okay, so let's start from the easiest one, right? These two are easiest one. X greater than equal to 0, y greater than equal to 0. Okay, it must be in the first quadrant, which is here, right? Must be here. So we draw all the graph in this first quadrant. Then let's look at 2x plus 3y equals 12, right? Less than 12, less than equal to. So let's look at the boundary, equals 12. So we needed to choose x equals 0, y equals 4, right? 0, 4, and the y equals 6. X equals 0. Y equals 0. X equals 6, right? Okay, so let's draw the graph. 0, 4, 1, 1, 2, 3, 4 is here. 6, 0, 1, 2, 3, 4, 5, 6. Which is here. And this is 6, 0, and this is the 0, 4. Then we connect these 2 points, right? It's connected. We just draw the graph in the first quadrant, right? We don't need other parts. Of course, you can extend it, but keep in mind, everything should be in the first quadrant. It must be here, okay? In the first quadrant, this is called the first quadrant, this is called the second, third, and the fourth, right? In the first quadrant is here. So which part, above or below? Right, let's look at, we test what? Test the 0, 0 point. So plug into here. So here is the 2 times 0. Sorry, I should not write here. 2 times 0 plus 3 times 0 less than equal to 12. Is that correct? Yes. All right. So it must be below, including the origin. Now let's look at this one, the second one. I use red color. The second 2x plus y less than equal to 8. Let's look at the boundary, which is 2x plus y equals 8. Okay, we choose x equals 0. So y equals what? Equals 8. Y equals 0. X equals 4. Okay, 8. So here is 4. So here would be 8. Right. We need a 0, 8. 0, 8. So here 0, 8. 0, 8. Another point is what? 4, 0. 4, 0 is here. 1, 2, 3, 3, 4. This is 4, 0. Then we connect these 2 points. Okay. So which part? Is this part or this part? Right? We need to test 0, 0 point. We plug into the 0, 0 point into this inequality. So 2 times 0 plus 0 less than equal to 8. Is this correct? Yes, right. 0 is less than equal to 8. So it should be, this is the test point, right? Should include the half plane, including this point, but should limit this region into the first quadrant, right? Into here. Limit the region into here. So it should be here. Okay. So now the feasible region would be another color. This region, this boundary, right? This is the boundary x equals 0. This is the boundary for y equals 0. And this line, and this line, right? So this is the feasible region. So since this is feasible, so the next thing we need to find the corner points for this feasible region. So we know this point is 0, 4. And then we know this point is 4, 0, right? This is 4, 0. And we know this point is 0, 0. So the only thing left is this point, right? This is the intersection of 2 lines, this red line and the black line. So we need to list a system of equations, right? This is the red line is 2x, black line is 2x plus 3y equals 12. The red line is 2x plus y equals 8. So you have many ways, right? So using the substitution method, we can use the second equation, right? Y equals 8 minus 2x. Then plug into the first equation, right? Then you can solve for x, then solve for y. And or you can just use the elimination, right? Because here 2x, here 2x, let's change a little bit. Let's multiply. If we want to eliminate x, we multiply -1 on the first equation. So it becomes negative 2x plus minus 3y equals -12. The second equation, we just keep it. So we add them up, okay? Add them up, so it would be -2y equals -4. So y equals what? 2. What is x? We just plug in any equation you want. Well, let's plug in the first equation, right? So 2x plus 3 times 2 equals 12. So 2x equals what? 6. So x equals 3. X equals 3. So we have this point is what? 3, 2 points. Okay. Now you have all the corner points. The next thing is you just need to plug in one, right? Plug into the what? The objective function. Let's use this a table. Plug in. Counterclockwise, we use the 0, 4, 0, 0, 4, 0, and 3, 2. Okay, this is the all 4 corner points, right? This is 0, 4, 0, 0, 4, 0, and 3, 2. Z is equal to 6x plus 7y. Plug in 6 times 0 plus 7 times 4, which is 28. Plug in 0, 0. 6 times 0 plus 7 times 0 equals 0. 4, 0. 6 times 4 plus 7 times 0 equals 24. 3, 2. 6 times 3 plus 7 times 2 equals what? 18 plus 14. This is 31. Which one is the, it asks you to maximize. So you need to find the largest number, right? 32. 32, sorry. Yes, thank you. 32. So this is the maximum value, right? It asks you to find the maximum value. So you will have the maximum value is, the max is 32 when x equals 3 and y equals 2. Okay, so these are all the problems for the review sheet.